1 mole of air is put in a container that measures 10 liters in volume. If the temperature of the air is kept at 20 degrees Celsius, what is the pressure of the air? So if you remember, we have the ideal gas law, which says that the pressure times the volume of a gas is equal to the number of moles in that gas times the gas constant times the gas's temperature T. And that is the ideal gas law. So, ideal gas law. And now it's asking us for the pressure of the air. So we can simply rearrange this equation to solve for pressure. So the pressure of the air is going to be the number of moles of the air times the gas constant times the temperature divided by the volume the air takes up. So I'm going to write down all of the stuff that we know. The number of moles of the air is 1. It says there's 1 mole of air in a container. So N is 1 mole. R, or the gas constant, is a constant, and it is equal to 8.31, about 8.31 joules per Kelvin mole. That's the gas constant. The temperature is given to us to be kept constant at 20 degrees Celsius, which is equal to 293 degrees Kelvin. Remember, Kelvin is equal to degrees Celsius plus 273. So that's Kelvin. And that's our temperature. And the volume is given to us as 10 liters. And if you remember, 1 liter is equal to 1 liter is simply equal to 1 cubic decimeter. So it's 1 cubic decimeter. So when it says that the volume is 10 liters, it's really saying 10 cubic decimeters. And 1 decimeter is 1/10 of a meter. So we can convert this to cubic meters, which is the standard unit required for this equation. So this becomes 0.01 cubic meters. You just divide this by 1,000, since 1 decimeter is 1/10 of a meter, and you have to cube that. So okay, so now that we have everything, we can plug it in. So this pressure becomes the number of moles, 1 mole, times the gas constant of 8.31 joules per Kelvin mole, times the temperature of 293 degrees Kelvin, divided by the volume of 0.01 cubic meters. And if you evaluate this, you should get that the pressure is equal to 243,483 pascals. And if you remember, a pascal is simply 1 newton per square meter. So it's units of force per square meter, or newtons per square meter. And this can be converted to roughly about 2.4 atm, or 2.4 times the atmospheric pressure at sea level on Earth. And that's the pressure in the container. And this is how you would solve this problem here.